Two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of the heat produced in series and parallel will be. So you have two wires. Forget about the entire question. We'll just go with a simple one. I mean, the very first statement. It's quite simple. Two wires of the same material and of equal length and equal diameter means what? They have the same resistance. Make sense? So we have let resistance of wire be R, right? Wires actually because of same length and everything. So we have the resistance to be R. So what else do we need to know? Well, let's figure out with the help of the formula itself. H is equal to I into hit Venus, right? So HIT into V. So we have, let us see what is that they given. So these are connected in parallel and series across the same potential. Means what? The voltage is fixed. Current we don't know. So it's better to express everything in terms of voltage. So I'll substitute I is equal to V by R. And we have V into V is V squared by R into T. Now, basically, the time and the voltage, this will be fixed. So everything is dependent on the resistance. So now, how do we go about doing this? See, what they're telling is the two resistors are connected in series and they're connected in parallel. So let's find the effective resistance when things are in series and find the heat as well. Case when we are connected in series, R series, that is the effective resistance, will be equal to R plus R, that is 2R ohm. Then the heat generated will be right H of S. We can write it as V square by RS into T. So this is let's just keep this. It will we can substitute it later. So we'll call this as equation 1, or let me substitute it off. No point, I guess. V square by 2R into T. It's not that complicated. So yeah, it's okay. So this we'll call it as equation 1. Remember, this is H of S. This is my equation 1. When we connect things in parallel, let's see what happens. So RP, okay, 1 by RP actually is equal to 1 by R plus 1 by R. So LCM is 2 by R. I mean, LCM is R actually. And the answer is 2 by R. Therefore, RP is equal to R by 2 ohm. So we have heat generated H of P is equal to V square by H of R of P into time. So if I substitute V square T dividing R by 2. So V square T into 2 by R. Right? So please understand this math. It's not that hard. V square by T by R into 2. So this is my equation 2. I could have written it a bit better actually. Let me not mix it up. Let me write it neat. H of P is equal to 2 times of V squared T by R. This is my equation 2. So now 1 and 2, what do we have? We have to find heat produced in series and in parallel combination would be what? H of S by H of P is equal to V square by 2R into T divided by 2V square T by R. So this is half of V squared T by R into R by 2 V squared T. Right? Again, simple math. We're taking multiplicative inverse when we are converting division to multiplication. So we have V square T common, R and R common. So this is 1 by 4. 1 by 2 into 1 by 2 will be 1 by 4. So what is the next thing? So, that's it. H of S by H of P is 1/4. Option C. Right? What can we conclude? See, I always told you we need to learn to conclude things. So H of S is equal to 1/4 of H of P. If not, H of P is 4 times of H of S. That is heat produced in parallel connection is 4 times that 4 times the 4 times 4 times the heat produced in series. Right? Think about it. If you cross multiply, this is simple math. Okay, so learn to conclude such way, it helps. So basically, this is your answer. Now you can have a look at it.